Hello students, welcome to my YouTube channel Dear Mathematics and also welcome to the new chapter limit. This chapter is very much important because a lot of other chapters depends upon the chapter limit, likewise derivative, integration, application of derivative, differential equation and so on. So let us go through the topic limit. So first of all, let us go through the introduction of a limit. The subject calculus takes its stand upon the set of real numbers and functions. So we are going to discuss about the topic calculus. In between the calculus, we will come across derivative, that is differential equation, then integral calculus, that is integration. So the subject calculus takes its stand upon the set of real numbers and functions. In calculus, we deal with two types of quantities. The first one is constant, the second one is variable. So what do you mean by constant? The value which cannot be changed, or can we say that it remains as it is called as a constant. As it is called as a constant. Variable, the value which can vary from place to place or situation to situation is called as a variable. Is called as a variable. It is denoted by small x, small y, small z, dot, 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 etc. Again, variable is of two types. The first one is dependent variable and the second one is independent variable. Then let us come through the values of functions. So in this topic limit, we will evaluate two types of values of a given function. The first one is the functional value at a given point and the second one is the limiting value at a given point. The functional value of f of x at the point x is equal to a, at the particular point x is equal to a, is denoted by f of a. That means we have to directly substitute the value of a in place of x, and then the other value, that is limiting value of f of x at x is equal to a is denoted by limiting value of f of x when x tends to a, not equal to a. So limiting value at a particular value x is equal to a is denoted by, we have to find out the limiting value of f of x when x tends to a. What do you mean by tends to a? X tends to a is not equal to x is equal to a, is not equal to x is equal to a. So you have to understand the arrow mark is placed for the word tends to. So x tends to a is not equal to x is equal to a. That means, so what do you mean by x tends to a? Suppose this is the value of f of x. Suppose this is the value of x. In the functional value, whenever we will put x is equal to a, suppose this is the point a, then here you will find out the functional value f of a. This is the range of the, this is the area of the functional value, and this is the area for f of x, and this is the region x. So whenever you will put x is equal to a, that means directly you have to substitute a in place of x, then you will find out f of a, and that is called as the functional value. But in the case of a limiting value, x, it is given that x tends to a. X tends to a means, suppose this is the point a, then you have to cover up a neighborhood of a. Suppose this is the point, suppose the distance is h. Suppose the distance is h, which is very negligible. h is very small, that means h tends to 0, very small value, then this point will be a minus h and this point will be a plus h. That means the open interval of a minus h, a plus h is called as the neighborhood of the point A. Is called as the neighborhood of the point A. And we have to check, or we have to examine the behavior of the function f of x when x approaches to A, when x tends to A. That means we can examine the behavior of f of x in both ways. The first one is we can check the behavior of the function when x approaches, we can examine the behavior of f of x in two ways. The first one is when x tends to A, or you can say that approaches to A, from left side, from left hand side, that means from here. And also we can examine the behavior of the function f of x when x approaches to A from the right hand side. And then we have to compare. Both the results, and that is called as the limiting value of f of x. That means in the limiting value of f of x, you cannot put the value of A here, just you have to check the behavior of the function f of x. What you are getting the result here, whenever you are moving from the left hand side up to the point A, not to the point nearest to A, and then again you have to check the behavior of the function f of x from the right hand side when x approaches to A, from the right hand side nearest to A, not equal to A. And then you have to compare both of the results, and then you have to find out the limiting value. If they are equal, then the limiting value exists. If they are not equal, then the limiting value does not exist. So let us check what are the results we are getting for the limiting value. Before going to the limiting value, first of all, let us find out the functional value here. Functional value of f of x at x is equal to 2. Given that f of x is equal to, these are the notes, and here it is the problem, and the procedure is here. Given that f of x is equal to x plus 3, the function is given by x plus 3, and we have to evaluate the limiting value as well as the functional value. Let us first starting from the functional value. Then when x is equal to 2, then f of 2, because we are determining or we are evaluating the functional value, that means we have to directly substitute the value of x in place of f of x. So it will be f of 2 is equal to 2 plus 3 is equal to 5. So functional value is f of 2 is equal to 5, and here it is the functional value. Then let us find out or determine the limiting value. Then let us discuss about the limiting value of f of x when the point is given to you x is equal to 2. First of all, let us plot the functional value in the given diagrams. When x is equal to 2, we are getting f of x as 5. F of x as 5. Now we have to go through the limiting value from the left hand side, because limiting value means there are two types of limiting values are there. The first one is left hand limiting value and the second one is right hand limiting value. That means first of all we have to check the behavior of the function f of x whenever x approaches to the given point from the left hand side, and then we have to check the behavior of the function f of x, and then again we have to go through the right hand side. That means we have to approach x from the right hand side to the given point, then we have to check the behavior of the given function, then we can compare them. So here it is the, when we are putting, this is the functional value, this is the functional value. Whenever we are putting 2, directly substituting the value of 2 in place of x, we are getting the result as 5, and this is f of a. This is x is equal to a and this is f of a. But we have to check this from the left hand side whenever we are going through the limiting value. Suppose I am, the given function is f of x is equal to x plus 3. Suppose I am putting there x is equal to 1.7. If x is equal to 1.7, then f 1.7 is equal to 1.7 plus 3, which is equal to 4.7. That means we are getting here 4.7. Here it is 4.7. Then x is equal to, we have to come across through the point 2. We have to approach the value of x nearest to 2. When x approaches to 2 from the left hand side, we have to go the nearest point to the point 2 from the left hand side. We have to come across from the left hand side, and we have to come closer and closer to the point 2, very nearer to the point 2. So I have first taken 1.7, then 1.8, then 1.9. You can also take 1.99. So you can come closer to 2, and then you have to check the behavior of the function f of x, what we are getting here. Then whenever x is equal to 1.8, f of 1.8 is equal to 1.8 plus 3, that is equal to 4.8. So we are getting here 4.8. When x is equal to 1.9, then f of 1.9 is equal to 1.9 plus 3, it is 4.9. That means here it is 4.9. That means first of all we have taken 1.7. We are getting 4.7, then we are taking 1.8, then we are taking 4.8, we are having 4.8, then we are taking x is equal to 1.9, then here we are getting f of x is equal to 4.9. Whenever x approaches to 2 from the left hand side, very nearer to 2, we are getting the result of f of x approaches to the value 5. Very nearest to the 5, not equal to 5. Whenever x, suppose we are putting here 1.99, then you will get here 4.99. Because in the limiting value, we cannot put the direct value 2 here, because 2 is the functional value. Whenever we will put 2 here, then that will be converted into the functional value. So we have to come across from the left hand side to the nearest point of 2, very closer to 2. Then you have to check the behavior of the function f of x. What you are getting? Whenever the value of x getting closer and closer to 2 from the left hand side, then value of f of x is also getting closer and closer to 5. Then we can express this in the mathematical form as x approaches from the left hand side, then f of x approaches to 5. That is, x tends to 2 minus. So what do you mean by 2 minus? Because these points are 1.7, 1.8, 1.9 are smaller than 2. That means 2 minus something, 2 minus 0.1, 2 minus 0.2, 2 minus, here it is 1.7, it is 2 minus 0.3. So these are smaller values than the given 0.2. So it is represented by x tends to 2 minus. That means we are approaching from the left hand side and we are taking the values those are less than 2. So we have denoted by as x tends to 2 minus, then f of x approaches to 5 when x tends to 2 minus. That means whenever we are approaching the value 2 from the left hand side, then value of f of x also getting closer to 5 from left hand side. Again, this is defined as the left hand limit and it is denoted by LHL. So the left hand limit can be expressed or can be denoted by limiting value of f of x when x tends to 2 minus. That means from the left hand side we are getting the value of f of x approaches to 5. That means the left hand limit is equal to 5. Then we have to discuss about the right hand limit again in the same procedure. Then moving towards to the limiting value from the right hand side. First of all, let us put here 2.1, 2.2, 2.3. We have to approach the value 2 from the right hand side. That means first of all we have to put 2.3. If x is equal to 2.3, then f of x is equal to x plus 3. That means it is f of 2.3 is equal to 2.3 plus 3. That means it is 5.3. So when x is equal to 2.3, f of x is equal to 5.3. Similarly, when x is equal to 2.2, then f of 2.2 is equal to 2.2 plus 3, it is equal to 5.2. It is 5.2. Just we are approaching to 2, the value 2 from the right hand side. Then you have to put 2.1. Let us put 2.1 and let us see what is the value of f of x here. Then f of 2.1 is 2.1 plus 3, it is equal to 5.1. So when we are putting 2.3, we are getting 5.3, 2.2, 5.2, then 2.1, then we are getting 5.1. That means whenever we are approaching to the value x is equal to 2 from the right hand side, the value of the function f of x approaches to 5 from the right hand side. Not equal to 5, approaches to 5 from the right hand side. So what we have got here? We have got here when x approaches to 2 from the left hand side, the value of f of x approaches to 5 from the left hand side. It is getting closer to 5. When x getting closer to 2 from the right hand side, then the value of f of x getting closer to 5, getting closer or nearer to 5 from the right hand side. That means the right hand limiting value is also equal to 5, and here as x approaches to 2 from the right hand side, then f of x approaches to 5, that is x tends to 2 plus. Why we are denoting or why we are using 2 plus? Because all the values are 2.1, 2.2, 2.3 are greater than 2. If they are greater than 2, that means they are little higher than 2. So we are using 2 plus sign here. Then f of x getting closer to 5 from the right hand side. It is defined as the right hand limit or denoted by RHL. And for this, due to this right hand limit reason, we can denote this expression, this whole mathematical expression in the mathematical form, short form, limiting value of f of x when x tends to 2 from the right hand side, then the value of f of x getting closer or approaches to 5 from the right hand side. So what are the conclusions we are getting here? Just let us see. So here, whenever we are getting 1.8, we are getting 4.8, 1.9, it is 4.9, then where we are getting 2.3, we are getting 5.3, whenever we are getting 2.2, we are getting 5.2, whenever we are putting 2.1, then we are getting 5.1. So you can see that when x approaches to 2, so when x approaches to 2 from the left hand side, f of x approaches to 5, the value of x getting increasing 1 by 1, 1 by 1, and it is getting closer to 2. So similarly, the value of f of x is also getting closer and closer to 5. So limiting value of, this is the left hand limit, x tends to 2 minus f of x is equal to 5. In the right hand limiting case, whenever we are getting closer to 2, whenever the value of x getting closer and closer to 2 from the right hand side, then the value of f of x also getting closer and closer to 5 from the right hand side. So in the right hand limiting case, we can also write down limiting value of f of x when x tends to 2. From the right hand side, we are also getting the same value. That means both of the limiting cases approaches to the same integer, that is equal to 5 when x tends to 2. So without writing both of the two cases, limiting value, left hand limiting value, right hand limiting value, just let us put down a short form here and the definition. By using the definition, we can have limiting value of f of x whenever x approaches to 2, either it is from left hand side or it is from right hand side, we are getting the same value 5. That means limit exists here. If both of the limit, left hand limit and is equal to right hand limit, if left hand limit is equal to right hand limit, then limit exists, and that is equal to a common value, because here it is 5 and the second one case result is also 5. That means both of them contains a common value. That means limiting value of f of x is equal to 5. And here, by using these two equations, we can combine both of them and we can form a new statement that is called as limiting value of f of x when x approaches to 2 is equal to 5, and this is the limit. Then let us have some of the fundamental words or notes based upon the topic limit, then you can proceed to the further example. So what are the conclusions we have got from the previous problem? Both the left hand limit and right hand limit approaches to the same value 5, and it is read as limiting value of f of x, limiting value of f of x at x is equal to 2 when x tends to 2 is equal to 5. When x approaches to 2 both from left hand side and right hand side, then the value of f of x approaches to 5. Then let us have some of the rest of the fundamental notes based upon the topic limit. So here these are the basic concepts based upon the existence of a limit. If limit, left hand limit is equal to right hand limit, then we can say that the limit exists at that point. If left hand limit is not equal to right hand limit, then we can say that limit does not exist at the given point. Let f of x be the given function. If left hand limit and right hand limit of f of x at x is equal to a are equal to a common value L, that means they approaches to the same value. The value of f of x approaches to the same value L, then we can write down limiting value of f of x when x tends to a is equal to L. That means left hand limit is equal to right hand limit is equal to the common value L. That means limiting value of the function at the given point x is equal to a is equal to L. Then examine the existence of the function, the limiting value of the function by using the diagram. So given that the function f of x is equal to 1 when x less than equal to 0 and 2 when x is greater than 0. It contains three types of values. X is equal to 0, it is then f of x is equal to, then f of x is equal to 1, x less than 0, then f of x is equal to 1, but when x greater than 0, then f of x is equal to 2. So let us draw the diagram here. When x is equal to 0, this is this horizontal line is for the value of x and this vertical line is the value for the y. So when x is equal to 0, then f of x is also equal to, then f of x is equal to 1. This is the value 1. When x less than 0, then again the value of f of x is equal to 1. That means towards the left hand side. But when the value of x greater than 0, that means we cannot include this point, because this point has been already included here. When x is equal to 0, then the value of f of x is equal to 1. When x is greater than 0, then the value of f of x is equal to 2. So from here, this diagram, from here we have, from the diagram we have left hand limiting value. That means whenever x approaches to 0, when x approaches to 0 from the left hand side, that means 0 minus, then the limiting value of f of x approaches to the point 1. Limiting value of the function f of x approaches to 1. But when we are approaching from the right hand side, that means when x approaches to 0 from the right hand side, that means 0 plus, then the value of f of x approaches from the right hand side to the point 2. So limiting value of f of x when x tends to 0 plus is equal to 2. That means they are not equal with each other. That means they are not giving a common value. Here it is the left hand limiting value, this is the right hand limiting value. Here left hand limiting value is not equal to right hand limiting value, so limit does not exist here. And here it is the solution of the problem. Then let us move towards to the last concept of this current video session for the topic of limit, and then we can conclude our video session for today. So here it is the next problem, and the function is like this: f of x is equal to x square minus 9 divided by x minus 3 with the given function, and we have to find out the functional value as well as the limiting value of the given function f of x at the point x is equal to 3. So let us start from the functional value. Given that f of x is equal to x square minus 9 divided by x minus 3. So when x is equal to 3, then the functional value f of 3 is equal to 3 square minus 9 divided by 3 minus 3. That means 9 minus 9 divided by 3 minus 3, which is equal to 0 by 0, and this is called as the indeterminate form. This is called as the indeterminate form. So many other indeterminate forms are there, and we will discuss later in the after this video session. Okay, so here we are getting the indeterminate form, and then if the functional value is in the form of or gets in the form of a indeterminate form, then we have to solve this by some basic mathematical operations, and we will discuss about them later in the next video session. But here, as the functional value is in the form of a indeterminate form, so we have to solve it by factorization method. Factorization method is one type of method among the out of the basic operation methods that we are going to discuss in the next video session. So if f of x is equal to x square minus 9 divided by x minus 3, then we have to use the factorization method. Factorization method is applied here. X plus 3 multiplied with x minus 3 divided by x minus 3, cancelling both of the common parts here, we are getting x plus 3. Now we can use the functional value, that means the substitution method. We can directly put when x is equal to 3, then f of x is equal to f of 3 is equal to, okay, this is f of 3 is equal to 3 plus 3 is equal to 6. So there are some of the problems which cannot be solved by directly substituting the value of the x is equal to the given value. and we have to use, because whenever we are going to put the direct value, we will get a indeterminate form here, and then we have to use some basic mathematical operations, and then we have to solve it. Then moving towards the limiting value of the given function. Then evaluating the limiting value of the given function f of x, and we have f of x is equal to x square minus 9 divided by x minus 3. After using factorization method, we are getting f of x as x plus 3. Now we have to approach the value 3 from left hand side and right hand side. Then we have to examine the behavior of the function f of x, and then we have to find out the limiting value. So when x is equal to 2.97, then f of x is equal to x plus 3. That means f of 2.97, it is 2.97 plus 3, it is 5.97. Similarly, when x is equal to 2.98, then f of 2.98 will be equal to 5.98. When x is equal to 2.99, then f of 2.99 is equal to 5.99. So when x approaches to 3 from the left hand side, then value of the f of x approaches to 6, because this is the value 5.97, this is 5.98, this is 5.99, 5.97, 5.98, 5.99, that means it approaches to 6, the integer 6. This is the functional value. Whenever we are putting 3 here, we are getting 0 by 0, indeterminate form. The functional value is 0 by 0. It is indeterminate form. But we are calculating now the limiting value. Here we have already evaluated the value is 6. But after the factorization method, we have evaluated this value is 6. Otherwise, the functional value is in the form of 0 by 0. So when x approaches to 3, then the value of f of x approaches to 6. Then the value of f of x approaches to 6, because 5.97, then the greatest value, then its next value 5.98, then its next value 5.99. That means it approaches to the integer. You have to find out the integer towards which these values are approaching. So you can also write down as x tends to 3 minus from the left hand side, then f of x approaches to 6. So limiting value of f of x when x approaches to 3 from the left hand side, the value of f of x approaches towards 6, and this is the left hand limiting value. Similarly, we can also write down, now we have to calculate the right hand limiting value. Okay, so let us find out the right hand limiting value. If we are putting x is equal to 3.03, then f of 3.03 is equal to 3.03 plus 3 is equal to 6.03. When x is equal to 3.02, then f of 3.02 is equal to 6.02. When x is equal to 3.01, then f of 3.01 is equal to 6.01. That means when x approaches to 3 from the right hand side, then the value of f of x approaches to again 6 from the right hand side, because 6.03, then we are getting 6.02, then we are getting 6.01. That means it is in the decreasing order and they are approaching to the integer, because very nearest value to the 6.01, the integer is 6. So this is the right hand limiting value when x approaches to 3 from right hand side, then value of f of x approaches to 6 from the right hand side. As x tends to 3 plus, that means from the approaching the value 3 from the right hand side, then f of x approaches to 6. So limiting value of f of x when x tends to 3 plus is equal to 6. So from the left hand limit and right hand limit, so from left hand limit and right hand limit, because the left hand limit is equal to right hand limit is equal to the common value 6. This is the common value. As they are approaching to the common value, that means limit exists here. So from left hand limit and right hand limit, we have limit x tends to 3 minus f of x is equal to limit x tends to 3 plus f of x, and they are approaching to the same value 6. So without writing these two left hand limit and right hand limit, just write down the limiting value without writing this is the left hand limit, this is the right hand limit, without writing both of the limits, left hand limit, right hand limit, just write down the limiting value. So the limiting value of f of x when x tends to 3 is equal to 6, and this is the final answer. As the left hand limit, right hand limit are equal, so you can also write down limit exists here, limit exists here, or you can say that limiting value of f of x when x approaches to 3 exists at the point 3. So in this current video session, we have just started the topic of a limit here, just the introductory part of a limit. Just we have seen the simple 3 examples and valuable examples based upon the limit. In the next video session, we are going to discuss about the algebra of a limit, the indeterminate forms, and some of the basic problems based upon the left hand limit and right hand limit. Till then, thank you.